Hello, I'm Dr. Harper. This video is a homework Excel tutorial, part C, in Operations Management Business Forecasting. So let's bring up the problem. Two time series are being considered and both contain random, seasonal, and linear trend components. However, the characteristic of the linear trend is sought. And as it turns out, the characteristic is different between time series 1 and time series 2. Both time series have a linear trend. What is a type of trend in each time series? And we see here it's going to be a step function, continuous trend. Well, let's see how to determine that. Let's take the data, Control-C, copy. Let's bring in Excel. Come down here a ways and let's paste it. Control-V and paste. And there it is. And so now let's enlarge this so we can see what we're doing. There we go. Now that we have the data here, what we can do is highlight this and insert charts and map it. We can see here the graph of the data is both are linear. There's a linear trend. We can see the linear trend, and there's a seasonality as well. However, you can't really tell the character of the linear trend until you seasonally adjust the data and filter out the seasonal component, and the trend component will emerge. So let's do that. First, let's take this. We're going to be blocking the data since it's seasonal. Control-C. Let's come down here a ways, and right here, and let's paste it. Let's transpose it, and then let's paste the values. There they are. Okay, now I'm going to analyze both time series. First time series 1, then time series 2. Let's change this to a TS1 and then a TS2 just to have more convenience. Okay, let's Control++, add a couple of lines here. Let's take 1 through 16, 4 years worth of data, Control-C, and then come down here. So now we have the actual quarters 1 through 16 for time series 1, 1 to 16 time series 2. Now we're going to analyze both of them. So let's start with time series 1. Okay, Control-C. Let's come down here and let's post it right here. The values, and there they are. Okay, and so let's bring the time series 1 up here. And now this is going to be year 1, year 2, year 3, and year 4, because we know it's 4 years. We have to put the 2's in, 3's in, and the 4's in. And so since we have this data here, the beginning of year 2 will start after 4 quarters, which is quarter 5. The first quarter in year 3 is after 8, which is 9. And the first quarter of the 4th year is after 12, which is 13. And there they are. So I can just copy those over. And there's my blocked time series. Okay, let's Control-C. Let's paste the values. And then from here on out, we don't need these values. We can delete them. Okay. Now that we know that it's a time series with a trend and seasonal component, let's put the titles in here. Quarter 3, got a little ahead of myself there. Quarter 4. This is quarter 2. 2 comes after 1 and before 3. There we go. So now I can plot this and see what it looks like as stacked data. Insert chart here now that I have the titles. And boom, that's what it looks like. We can reduce this down a little bit. Not that much. That's good enough. Okay, so now we can see that it does have a seasonal component, and it does go up, and so we really still don't know what type of a trend it is. We have to seasonally adjust it. Okay, so now we take the slope, and over here to have the independent variables, we'll just have 1, 2, 3, and 4. Now we have the slope function of the demand data. This is the y variables, the dependent, comma, it's dependent on the time. F4 to freeze that. And now I can copy that over. That's going to be the slope for each one of the years. I mean, each one of the quarters through the 4 years. So this will be this. This is the trend. This is the seasonal. This is the seasonal trend. Now we can seasonally adjust the trend by taking the average. So the average of the slope, or the average of the trend, is going to be the seasonally adjusted trend. So now we can calculate our seasonal indexes here, which will equal our seasonal trend divided by our seasonally adjusted trend, F4 to fix it, and copy it over. And there's our seasonal indexes. So now that we have our seasonal indexes, the next thing we want to do, this is a time series. The next thing we want to do is our seasonally adjusted time series 1. Okay? And so let me just take this and put it here. Take this, actually take all of this. Put it here. Now, to get the seasonally adjusted time series, you take the data, the seasonal data point, divided by the seasonal index, F4 to freeze it, because we're going to divide each one of these by the index to get your the seasonally adjusted data. Same thing here, equals our data divided by a seasonal index, F4. Same thing here, our data divided by our index, F4. And finally equals our data divided by our seasonal index, F4 to freeze it. And notice 140, 140, 140. It's the same all year. And sure enough, 540, 940, 1340. What we have here is a nice step function. So we can plot this thing. We can still get the slope here. Copy that over. Okay. And notice the seasonally adjusted, the annual slope, the annual trend of the seasonally adjusted quarterly time series is 400. Because it goes from 140 to 540, which is 400. But we can also take this and plot it. And we can actually see it's a nice flat line every single year. Year 1, year 2, year 3, year 4. Okay? Very good. Now then, let's bring this down here. Let's bring this down here. Now if we want a line plot, which I think we do, we have 1 equals 1 plus 1, and this is going to be all the way to 16. There we go, 16, because we know there's 16 data points. Okay, now, this one is going to equal year 1. Quarter 1 of year 2 is going to be quarter 5. 9 is going to be the 3rd year. And then finally 13 is going to be the 4th year. And so I can just populate these. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then finally 1, 2, 3, 4. And there they are. Very good. Now the reason I'm doing this is I just simply want a line plot. So I come up here, I say insert, data, and there's my nice little step function on a line plot. Okay, so there's the line plot that we can use to tell that's the actual trend character of time series 1. So let's do the same thing for time series 2. Okay, So let's reduce, let's bring this up here. Bring this up here. And then let's, where's this one? Here it is. Let's bring this up here. And then let's take time series 2. We'll do the same thing for time series 2. We'll see what kind of a trend there is underneath that. Control C. Now we'll come down here below the other things and just say, okay, let's see, where are we here? Column C. Come down here, column C, about right here. And then Control V and paste this thing. And there's the data. Okay. Again, now that we have the data, let's delete this. Let's bring this up. Let's block it. This is going to be, again, up here. Let's see here. It's going to be year 1, 2, 3, 4. And it's going to be quarter 1, 2, 3, 4. And so the quarter 1 of year 2 is going to be quarter 5. This will be quarter 9. And this is quarter 13. And then we copy these over like we did before. And there they are. And let's copy these and make sure that they are data. And there's no links. And so we delete this. And let's just take away the borders here. We don't need the borders anymore. And then over here, let's take away these borders. Gets in our way. And there they are. Okay, let's come to Arial. Okay, the same thing. Let's take the slope. And with the slope, we're going to have a 1, 2, 3, 4 again. Equals slope of our data, which is dependent on our time, F4 to freeze, and then copy that over. And then the seasonally adjusted is the average is the average of the seasonal slope. This is seasonally adjusted, and now we have their seasonal indexes. And then when we do this, if you recognize what's happening here, some very interesting things happen. Okay, first of all, we have our indexes, and we come up here. Our index is up here, 0.591412, 0.591412. They're the same. Well, also, the slope is the same. 2, 360, 560, 480. 2, 360, 560. But it's not the same time series. But the indexes are the same, and the slopes are the same. And the seasonally adjusted slope is the same. Okay? But it's a different time series. Okay. So now, let's take this again and put it down here. But we don't want this. We're going to generate it for the seasonally adjusted time series 2. Okay, now we're doing it for this. Okay, just like we did before, this will equal the seasonal data divided by the seasonal index, F4. This equals the seasonal data divided by the index, F4, equals the seasonal data divided by the index, F4, and the seasonal value divided by this index will give you the seasonally adjusted value. And copy that down, and notice it's not the same seasonally adjusted value. Okay? And the slope here is going to be these, comma these, F4, and notice it's going to be 400, and the average is 400. So the 400 is the same here. Okay. Again, what we want to do is to create a line plot to see exactly what the character of this seasonally adjusted time series is. So Control C, bring it over here. Let's see, where did I do this? It's behind this. I did it on column I kind of went to the same place. I'll do it this way. Column I, here we go. Data, and this is 1. This is equals 1 plus this, and this goes all the way to 16. And oh wow, that was good. I did right to the 16. Okay, then come back. Say, okay, now this second one here is going to be this one. 9 is going to be the beginning of the third, and then 13 is the beginning of the fourth. And then let's copy this. Copy this. Then come over here. Copy this. And there it is. Let's take all of this. And let's just make sure it's data so it will plot evenly and quickly and well. We don't need this anymore. Okay, now we take all of this and we come up here and plot it, insert data, and there's our nice continuous trend. That's a seasonally adjusted trend line. Okay, and there it is. Okay, so we can tell that time series 1 has a step function and time series 2 is a continuous trend. Now both time series have the same seasonal indexes. We saw that. What's the seasonal forecast? The seasonal forecast for quarter 17 for each time series. Okay, well let's see. Let's bring this up here like this. Let's see what this is. Come back here. We did do it. Okay, for time series 1, the seasonal forecast, I guess we didn't do it, is right here. Let's bring this down and let's do the forecasts. That equals the intercept of our data, comma our time, F4, plus our slope times our year, which is 5. And so there's our forecasts. So for quarter 1, it's 870. And sure enough, 870 for time period 17. And then down here, we want to do the same thing. So let's take, move this down 1 row. And let's do our forecast. Equals the intercept of comma our data, F4 to freeze it. Okay. That's true, but I didn't complete it. Intercept. That was the intercept, but I'm not done. This, comma, or intercept, F4, in parentheses, plus the slope, which is 200, times our year, which is 5. And so now there's our forecast for the year 4, and this is 875, and sure enough, it was 875. Good. Both time series have the same seasonally adjusted annual slope. We saw that, 400. Seasonally adjusted annual slope. In other words, for time period 1, seasonally adjusted is 400. Time period 2, seasonally adjusted slope is 400. Okay, that's good. Annual slope for the quarterly time series. What is the seasonally adjusted forecast for quarter 18? Okay, let's come back here. Okay, for quarter 18, the forecast down here. Okay, for the years, comma the indexes, F4, plus the slope, times year 5. And so there's our forecast for time period 16, 17, 18, and 19. So for it's 1740 for time series 1. Time series 1, there it is, 1740. Okay, now for time series 2, with a continuous trend, we'll have our data, comma, F4, in parentheses, plus our slope, times our year, which is 5, and now it's 1750. 1850 is for quarter 18, and 1850 for quarter 18. Okay, and so here are the plots. Here are the tables for the seasonal forecast and seasonally adjusted forecasts for the future. So that's all I have for Part C Excel tutorial. I hope this helps. Take care.